Okay, so welcome to the first lecture on data structures and algorithms. In this lecture, I hope to take you through what you can actually learn from the project, and also what kind of projects do we plan to do in this for this course actually. Right? Okay, so before I do that, let me try to introduce the whole subject matter of data structures. My take on this is as follows. Due to the large number of devices that are handling data at present, or a large number of devices that are actually generating more data, the amount of data that is being handled is getting voluminous, right? So you could also think of several examples in order of scale. So one quick example, as computer scientists often can think of, is a small compiler symbol table of a medium-sized program. It essentially records the data that is available in the program in terms of variables, functions, the parameters that you pass to a function, their types, values, so on and so forth. So it is some kind of data we kind of represent in a symbol table. The next probably order of magnitude bigger amount of data is one can think of as a telephone directory, right? So there essentially you list everybody who has a particular telephone number and their address and possibly other things. Right? Now a bigger order of magnitude would be let us say a digital library archive, right? So that is a big experiment going on these days. You want to somehow digitize the content in most libraries, maybe by scanning them a page at a time, so on, a book at a time, so on and so forth, so that you could actually read manuscripts maybe even published 100 years ago and possibly search through these manuscripts published 100 years ago, right? And you can imagine the size of data that would possibly be part of this or generated as part of this project. Probably a next order of magnitude is what I would think of as a search engine, where typically it has to index and also keep track of all the data that is being generated every day, right? Another application is, let us say, our famous example or famous project of trying to create a number or a unique identification number for everyone in India, right? So that is the project that is happening currently, and when it is completely done over 5 or 6 years, you would expect that every Indian in this billion-sized set would get one number, right? And not just a number. As part of that number, you have to store details like the person's name, age, address, and maybe his ancestral details, at least up to 1 or 2 levels, right? So occupation or educational details, several things may come up as part of this data, right? So imagine the amount of data that will be generated, and certainly it will be quite huge actually, right? So another statistic that you may worth consider is that every year we produce as much digital data as is there in the last, let's say 20, 30 years, whenever we started producing digital content, right? So the amount of data we are trying to handle is increasing at an exponential rate, and something has to be done about it. And that's what we want to think of as how to structure this data, right? One aspect of this whole data structures problem is to structure the data that is largely available in the online forums actually, right? Okay, so let us think of what do we do with this data, right? So think of a telephone directory, a very simple example. At least when you had these large thick books called telephone directories, now they are no longer exist. They also became digital, right? But still, even then, what would we normally do? We would look for a person name and want to find his or her telephone number, right? So think of a medium-sized city which will have, let us say some million entries, right? That's not unusual, right? And you want to search for a name such as Rajiv, right? A common name after all, right? Now, if you do not know how you are arranging this telephone directory or what is the order in which these entries are listed in the telephone directory, you will have to probably start from the first entry and keep on looking for entries one after another till you find your required entry, right? So what you can actually think of is that on average, this search will take about 500,000 attempts before you find your required entry, right? Simply because there is no order in the data. Now think of, well, actually you might say that is not how telephone directories are ordered. They are actually arranged in terms of some name or location or whatever it is, right? So in that case, if you know that they are arranged by name and you know that R comes at the fag end of the alphabet, so you would probably start flipping 3/4 of the directory immediately. You won't start somewhere at A or B. You would directly start at some place, right? So it means that the way you order your data, the way you structure your data has certain impact on the kind of things you can actually do on the data in an efficient manner. Otherwise, think of poring over 500,000 records. It is humanly impossible actually, right? Okay. So the key motivation from this example is that we need mechanisms to actually store the data and also to efficiently access data. Right? Be it a search engine or be it a telephone directory or be it our unique ID project. Right? Okay. So essentially the study of those mechanisms is what we call the field of data structures. Right? Starting with even elementary data structures or very simple mechanisms all the way to specialized mechanisms developed for special applications. Right? Okay. So it also is no surprise thus that any computer science curriculum anywhere in the world will probably have this data structures as a very first course, if not a second or whatever, right? So, which means that the computer science community essentially understands the importance of data structures to the whole field of computing also, right? Okay. All right. So, what do we cover as part of this project? Or as part of learning data structures, we walk through elementary data structures or fundamental data structures, so-called arrays, stacks and queues, hash tables, and they are not the only ones. We'll also look at pointer-based data structures such as linked lists, trees, heaps, etc. And we'll also look at special data structures such as graphs and also amortized data structures. So before the whole idea about this learning by doing is to essentially know some practical application of the item or the object we want to study. So even now, the impact or the flow of thought will be that we want to first see what are some practical motivations to consider each of these data structures. Right? So suppose you want to use or you want to do a project using a stack. So there must be some big practical impact of using the stack in that particular project that will help you solve the problem at hand very efficiently. Right? That will be the key concern. Right? Okay. And that is natural because it is by practice that you can gain deeper insights and also understand the implications of using a particular data structure. So there will be enough practice problems or practice sessions where you will be asked to kind of solve simple problems using one or two data structures. So you will then appreciate the ideas behind the data structure as well as the implications and the reasons this data structure helped solve the problem efficiently. Now, unlike programming courses, emphasis here will be also on correctness and efficiency, right? So you could solve the problem in possibly many different ways, but when you use the right data structures, when you make the right choices, then you will know that your solution is also very efficient. Not only that, you should be able to also answer questions such as why is this solution working, why is this correct, will it work every time I run the program on any input, right? So these are what we call as correctness criteria. Right? So to understand these two things, there may be some elementary analysis one has to do. This is what you learn in asymptotic analysis or discrete mathematics or some such related areas actually. Okay, all right. So the list of topics presented earlier did not have any much background on why they were listed in that order. So right now the attempt will be to see that these are the data structures and in some order of increasing complexity. So we can try to understand why we go through this order. Okay. So first thing we will see is are there any problems we can solve without using any data structures? but still trying to understand why data structures is important, right? So certainly there will be several such problems, and I pick on one problem called processing integer arithmetic, right? So very simple problem, and we'll still appreciate the need for better data organization, right? Okay. Now we'll also talk about analysis of algorithms and the need for data structures. So the need for different access patterns on simple data structures, and that's what gives us in a way stacks and queues, right? And also the limitations of array-based data structures. So arrays, as you may know, is one of the fundamental or the simplest data structure one can think of, and clearly it will have certain limitations also. And once we understand those limitations, then we can appreciate other data structures that go beyond these limitations, such as linked lists or so on and so forth. Then we will study hashing and trees. In a way, these essentially mean that, or these can actually enhance the scope of the application that we are trying to solve. So for instance, if you want to build a symbol table for a compiler, you may need to use some kind of hashing, right? So that's why we want to consider such data structures. Okay, now then we move on to some advanced data structures also, such as those that are used for efficient searching especially, and also look at graphs for a couple of weeks. The rest of the topics can be tailored according to the flow of the lecture, right? So if we think that one particular aspect is very interesting, then we can find more about data structures that have a certain kind of characteristics that help us appreciate these data structures.